Welcome friends. In this video we will learn how to regulate Java memory settings of our Java process. So suppose we launch a Java process by calling Java my class. Then it runs our Java process and it sets the values of the heap size and the stack size as default values, whatever are the default values for that platform. So it runs the process with default settings. But if you want to regulate the heap size, stack size and other things, we can do that with configuration parameters. So the first one is -xms. It is used to set the minimum heap size. So here we have given it 512M. So basically M corresponds to MB and it will set the default heap size as 512 MB. If we give K, then it will be 512 KB. Similarly, we can use G for GB. There are other similar word options for different memory units. So basically we can configure it in bytes, KB, MB, GB, whatever we want. And if we don't define it, its default value is 1/64th of the physical memory available on that computer. So this is the default value for it, and otherwise we can define it by using the -mx configuration parameter. And this default value lies between 8 MB to 1 GB. So if the 1/64th value of physical memory is less than 8 MB, it will be, then the default value will be 8 MB. And if 1/64th is greater than 1 GB, then it will limit to 1 GB. The next parameter is -xmx, which is used to configure the maximum heap size. So here, for example, we have configured the maximum heap size as 1 GB. And we can configure it in KBs, MBs, whatever we want, as shown in the above example for minimum heap size. So using this parameter, we can govern the maximum heap size. And as already told, -xms is the minimum heap size. And the default value for maximum heap size is half of the physical memory or 1/4 of the physical memory, depending upon the physical memory available. So if the physical memory is less than 192 MB, in that case the default value of maximum heap size will be 1/4 of the physical memory. And if it is greater than 192 MB, then the default value for maximum heap size will be 1/2 the physical memory. So 192 is the limit. If less than that, then 1/4, and if greater than that, then half. This is the default value. If we don't define -xms, this is how maximum heap size is regulated. And we can configure it in MBs, KBs, whatever unit we want. And needless to say that we can configure both these limits together as well. We can configure -xms and -xmx together, as shown in this example, where we're configuring minimum size as 512 MB and maximum size as 1 GB. And since xms is minimum size and xmsx is maximum size, it is obvious that minimum size can be not greater than maximum size. The best it can do is that it can be equal to maximum size. In that case, the Java process will start and continue to run with a fixed heap size, but it cannot exceed the maximum size. So another interesting parameter to learn is the nursery size. So it is denoted by minus xns. And nursery is part of the heap, and it is that part of the heap where the young generation objects live. So after the objects have passed a certain amount of time, they are promoted to old generation. And in the new JVM there are different garbage collector cycles for both of them. So we have young generation heap and we have old generation heap. So we can define the young generation size, and whenever this size will exceed, automatically the garbage collector for the young generation will start to run. So there are different garbage collectors for different generations. So as soon as this size exceeds, the young generation garbage collector will start to run, and it will free up some memory. So it is also a useful parameter in regulating the heap. And since it is kind of a sub part of the heap, it can also not exceed the maximum heap size. So we can define the nursery size as here we have defined the nursery size as 10 MB. So depending upon our use case, after memory study of our application, we can define it according to the size that we want. So as I told earlier, that when the objects have lived for a sufficient amount of time, or when a certain limit is crossed, the objects are transferred from the young generation to the old generation. So what is the threshold? How is it decided that this is the time to promote the objects from young generation to old generation? It is known as keep area ratio. So it is configured by the keep area ratio configuration parameter. So its default value is 25%. So when 25% of the total heap size is full, then this cycle runs of transferring the objects from young generation to old generation. If we want, we can override this as well. So when launching our Java process, we can change it to 10%, whatever we want. So default value is 25%. So these are some of the important parameters that we learned that can help us regulate our heap size in our Java process. So as a revision, these parameters were minus xns and minus xx keep area ratio. So this is kind of min heap, this is max heap, this is nursery, and this is the ratio of promotion from young to old generation. So This is some of the parameters that which we can use to regulate our heap size. If you want to check all the heap parameters of your Java process, you can run this command. So you can run java -xx, and you can pass this parameter print final flags. You need to write minus version, and then you can grep heap size. So using this command on Linux, you can know all the configuration parameters related to heap. For Windows, this command remains same. The only difference is instead of grep, you do find string and you write heap size. So this way you can know all your configuration parameters related to heap. Now let's talk about the thread stack for a while. So the thread stack is regulated by -xss parameter. So this is the value of the memory allocated to the stack of each thread. So you all know that when we start our Java process, our application starts in the daemon thread, in the main thread, and apart from main thread, there are many daemon threads also running. And in the code, you can generate further more threads as well. So whatever you set your value, for example, you set 50k. So here 50 KB of memory will be allotted to stack of each of the threads. So the more memory you are able to allocate, those each of the stack will perform a bit better. So we can combine all these parameters together. We can define the nursery size. Maybe we can say it to be 10 MB, and we can define the heap area ratio. Maybe we give it 50%, and we can also define our thread stack size as 50 KB or whatever we think is appropriate, and then we can give our class name. So these are some of the basic configuration parameters. For a detailed list of all the configuration parameters, I will add the official documentation link in my description, and you can check them out. Thank you.